DBSCAN is a powerful cluster algorithm, and it is mostly used for complicated data sets, but not data sets that are too big, because DBSCAN have to actually go to every point. Since it has to examine every single point in the data set, then it's not a very good algorithm for large data set. It's good for complicated data set, for the data sets that have multiple dimensions, but it is not very good for larger data set. Let's talk about what DBSCAN is calculate when it's going through each single point. DBSCAN generally focuses on where the density of the data is. And all of that, you need to set it yourself. You need to specify how dense do you want each one of the clusters to be. It will ask you for the number of neighboring points, and it will ask you for a radius, which is called epsilon. Then what it does, it goes to every single point. It will draw a circle, or I shouldn't say circle, a sphere, and then it will figure out how many data points are inside of that sphere. It's not done yet. It has another step. Remember, we said DBSCAN is going to ask us for a number of points as well. So when it is looking around, it is looking for how many neighbors it finds in that sphere around the data point. And then imagine I say, I want you to make sure that inside of that sphere you have 5 neighbors. Okay? And then DBSCAN looks at it, each one of these points, it will look at it. If they were 5 or more data points inside of the neighborhood, then it will consider it a core point. So that point is going to be assigned as a core point. If it does not have as many neighbors as it's supposed to have, that is going to be a border point. After it came up with the border points and core points, it will start connecting all of these core points together. Okay? All of these core points that are beside each other are going to form a cluster. So as you can see, we don't need to say how many clusters you're supposed to make, and our clusters are not necessarily supposed to be like a block. It can be any shape. It can be a circle. It can be anything. And because it would just look around and see how many core points are beside each other, and it will connect them. And it's not done yet. And it goes and it finds all of the border points, and it will connect it to the actual cluster as well. Okay? But then, so these are the neighboring points. Okay, these are the border points that did not have enough neighbors. Some of the neighbors of these points are actually a core point. Another thing that you have to keep in mind is that DBSCAN is very good at recognizing noise as well. The reason for that is that it's true that it is connecting all of those border points, but then the points that are close to border points are not considered part of the cluster. Why is that? It's like, for example, when you're going to a party or something and they say, okay, you can bring a +1. So you can bring a +1, but your +1 cannot bring a +1. So that's how it is. Each one of these core points have the ability to bring the points that are close to them, that are border, but they are in their neighbor. But these points that are border points and are not core points, they cannot bring their other points with them. Because of that, DBSCAN is very good at recognizing noise, and it's very good at dealing with complicated data sets. But again, it's true, it's powerful and all of these stuff. You have to give it correct hyperparameter. Okay, if for example you are making the epsilon, which is the radius of this sphere, too big, then what's going to happen is a lot of noise are going to be part of your cluster. If you're making it too small, it might separate clusters from each other.